Okay, so hopefully what you figured out was that you could think of this as the top part of C and this as the bottom part of C. And then you could think of this as the top part of A and this as the bottom part of A. And we needed to add to, of course, the top part of C and the bottom part of C. If you think of all of these rows and these rows as being blocks, then you find out that the top part of C is computed as the top part of A times B plus the top part of C. And the bottom part of C is computed as the bottom part of A times B plus the bottom part of C. And then if you want to write this as an assertion, so that we get our partition matrix expression, then you can think of that as this, with a hat on each of the C's in order to indicate original contents. Or alternatively, you could think of this as two equations. Sometimes I do one, sometimes I do the other. All right. And what do you notice? We pick how to partition one of the operands. That tells us how to partition another operand. That then tells us how the pieces are computed. And that then tells us what the partition matrix expression is. And then you can take the partition matrix expression and come up with loop invariants. And once you have the loop invariants, then the algorithms are predetermined. Okay, so go and find the loop invariants, go and find yourself some more algorithms for performing matrix-matrix multiplication.